Here we go, here we go, here we go. Right, okay. So we've been talking about this, natural selection business, and clearly it can create change. And in fact, we can see change happening over pretty short timescales. But what about generating new species of living thing? Can it actually do that? The answer is yes, and I'm going to. But it's one that you could actually see for yourself. It'd probably be pretty safe because it's out in it's out in a part of the country that invented social distancing before it was cool. And it might be a couple of days drive from here, but it's the sort of place I used to visit on spring break all the time. And it's an example of a mode of speciation. That's the word for the formation of new species, speciation. Love you, sweetie. And there's several ways that speciation can happen. That's about another week's worth of lectures in my upper division class, but I'll focus on what's called allopatric speciation. Again, you will never have to learn the meanings of all these words, but it does help some people retain them. Allopatric is Greek for other fatherland or different fatherland. Your patria in Latin is your fatherland. And if you love your patria, you're patriotic. And allos is Greek for other. So other homeland or different homeland. And it goes like this. You start with a population of an existing species. And a population is a group of individuals that can all potentially interbreed. And then something happens to divide that population in two. One way this can happen is that some individuals from that population will migrate across a barrier that they don't usually cross to form a new population. This is what would have happened in the Galapagos Islands. You have these finches living in this island group, and finches are pretty small birds, and they don't normally cross open water. They normally stay pretty close to the plants that make the seeds that many of them feed on. But occasionally some of them will do it. They might get blown off course by a strong wind, or just generally get lost, or maybe their cell phone connection goes down and Google Maps doesn't work or something like that. And you'd have a few finches that would go from one island and set up a population on another island, separated from the first by a water barrier that finches don't normally fly over. So that's one way you can get one population divided in two. Either some individuals migrate to form a new population, or the old population gets split by a barrier. And I'll show you an example of what that barrier might look like in just a minute. But the barrier could be anything from a river changing its course to volcanoes coming in to, oh, yes. All right, my wife has brought me something delicious. Anyway, where was I? Momentary distraction. Yeah. So that it could be volcanoes coming up. It could be a shift in a river channel. It could be, the drying up of a river that used to connect two lakes or something like that. It could be a lot of things. But one way or another, the old population gets divided by some barrier that they don't normally cross and becomes two populations. The separate populations then progressively become more and more different from each other. And that difference is caused in part by natural selection. Think back to those birds on islands. Maybe you've got a bird population on two different islands, and one island is drier or moister, or one island has a different plant species that has bigger seeds or something like that. That's something that those populations are going to have to adapt to. There's other factors that I'm not going to go into, like something called genetic drift. and something called the founder effect, which we need a little bit more background on genetics to be able to talk about intelligently. But one way or another, the populations become different, and if they become so different that they lose the ability to interbreed, we end up with new species. Again, this is not the only way it can happen, and I'm leaving out an awful lot, and I've got an annoying cat screaming at me. But yes, you. But this is how allopatric speciation works. And here's my case study. That's a fairly typical view of the desert surrounding Las Vegas. Vegas is about, click, maybe 50 miles away from where this picture was taken. This is a pretty typical landscape in southeastern California and southern Nevada on a desert called the Mojave Desert. And you will notice that there's not a great deal of water visible in that picture, and that, in fact, is why they call it the desert. Duh. I don't know if you can see this on the side, but this is an annoying cat. Anyway, that's a pretty typical view. Very dry, very harsh in summer. Death Valley is out there, and that's the place that recorded a temperature of, I think, 141 degrees Fahrenheit one year, setting a temperature record, certainly for North America. Pretty rough. But if you do a lot of hiking around there, as I have, you can find things like dry, flat areas that are covered in sediment and rock salt. They basically look like, because they are, dried up lake beds. The bottoms of lakes that don't normally have any water in them. Shoot, the bottom of Death Valley used to be a great big lake. You can find deposits of sediments, silt and mud and things like that, that were laid down at the bottoms of ancient lakes and rivers that don't have any water anymore. You can see one example on the left. That's a place where a pretty good sized stream, or maybe even a small river, cut a channel through a ridge of volcanic rock. And, well, now that river doesn't flow anymore, but you can still see the old channel in the middle of all that volcanic rock. If you go to Death Valley National Park and hike up a spot called Mosaic Canyon, you hike up this amazing canyon that's been carved and polished by an ancient stream that used to have waterfalls. That picture you're looking at on the right is actually a small waterfall in Mosaic Canyon, except there's not any water there, except very briefly when you have a heavy rain, which does occasionally happen, but not very often. Map all of these, and you'll find that the Mojave Desert used to be quite a bit cooler and quite a bit moister, quite a bit wetter than it is today. You can even find things like this. That's a road in Death Valley National Park, the Beatty Cutoff Road going from the Visitor Center to the town of Beatty, Nevada. And when they were building the road, they cut through a ridge made out of gravel. And this is what that ridge looks like in cross section. This is where they cut through the ridge, and it's made up of rounded pebbles laid down in kind of curvy, along curved lines that we call bedding planes. Not to keep you in suspense, but this is basically what a pebble beach looks like. If you were to go to a lake like Lake Superior that's got a pebble beach on it, and if you could bulldoze a trench right through the beach, this is what you'd see. You're looking at a bulldoze cut through a beach made up of smooth, rounded pebbles on the shores of a lake that has not existed for thousands of years. The lake is long gone, but it left behind these ridges like a ring around the bathtub, as it were. And there's lots of this stuff. And 10,000 years ago, this is a map of what the desert would have looked like. That dashed line is the California-Nevada border. Las Vegas would be kind of, down and to the right a little bit. That blue line is the Colorado River. And all of those, let me see, you can't really even see Los Angeles here, but all of those blue spots are ancient lakes, and all of those blue lines is an ancient river system. And that big, let me see, that lake, that really elongated one that's closest to the center, that is the lake that used to fill what is now Death Valley. So there's this whole network of rivers and lakes flowing through what is now very harsh desert. And that was only 10,000 years ago. That sounds like a lot, but it's about the time that the first Native Americans started showing up on the scene. One thing that has been found is there's places where people have found artificially dug fish ponds and fish traps on the shores of lakes that now have no water in them. So there were people living on the shores of these lakes, making use of, their fish and probably plants and things as well, back at a time when the climate was considerably cooler and moister. And they were people, not different from modern humans in any way that matters. So not actually that long ago. The only place you can get a sense of what that used to be like is there's a few places in this area where you have, there's enough underground water, there's enough groundwater to flow to the surface and make permanent springs. There's a number of these springs preserved at a place that I wish I could take everybody to go see. We have to maintain social distancing, so ideally we could just rent a fleet of 22 personal limos for everybody and drive out there and spend some days camping out there, properly socially distanced, of course. And you could visit Ash Meadows National Wildlife Refuge, which preserves a number of these isolated springs. They're just these ponds in the middle of the bleeping desert, places where fresh water is percolating up to the surface and feeding these ponds and feeding little streams that flow from the ponds. And this is one of those ponds. This is Crystal Spring, and it preserves remnants of the life that used to live in these much, much larger lakes and rivers that used to fill what's now the Mojave Desert. And if you go to Ash Meadows and you sit, as you can, on the edges of these ponds, you can find this. This little fish is called Cyprinodon nevadensis, aka the Amargosa pupfish. It's about an inch long. They're a lot of fun to watch because the spring is absolutely transparent. It's just beautiful, crystal clear, glass-like water. It's not really deep, and the fish live in the shallows. They feed mostly on the algae that grows on the rocks, and the males are this beautiful blue color. It doesn't show up well in this picture, but the males are this gorgeous turquoise blue, and here's sexual selection going on. The females look a little more drab, and the males are constantly showing off to the females. So the males are basically swimming over these algae-covered rocks, going, hey, hey, baby, hey, over here, can I get your number? Hey, baby, man, you look cute. Hey, come over here. Hey, you, back off. Hey, come over here. Hey, she's mine. It's like the most toxic meat market bar you've ever been in. Or I dimly remember I was never a member, but I went to a couple of frat parties when I was a freshman back in my hair metal days, and there were some that went kind of like that. The females don't usually seem to be very impressed, but the males are very persistent, and it's a lot of fun to watch. And be glad it's not happening to you. Anyway, So that's what you'd see at places like, Crystal Spring or King Spring in this picture, or several others in and around Ash Meadows. Drive 5 miles away and you'll come to an area that's now so fenced off you can't even get in. This is an older picture that I took, seen through the chain link fence. It's a crack in the ground, and it's maybe 10 feet wide down at the bottom, and it's very hard to get down into. They built some steps. A ladder you have to climb down, and there's water down at the bottom. That water leads you to, there's a whole system of underground caves that nobody has ever fully explored. And back in the 70s, a couple of people went scuba diving in those underground water-filled caves and never came out. Cave diving like that's very dangerous because you can't just float to the surface when your air is running out. If you get lost, you're in real trouble. So we don't even really know what's down there. But in the upper layers of that water-filled crack in the ground, which, by the way, is called Devil's Hole, there is a population of a different species of pupfish, Cyprinodon diabolus. It's only about half the size of Cyprinodon nevadensis, the one that you just saw. It's actually missing a fin compared to the others. And it is only found in Devil's Hole. The population is at its best, it's maybe about 200 individuals. They were having some problems with a population crash a few years back, and there were fears it was going to go extinct. But yeah, the entire population of this species is restricted only to Devil's Hole, that crack in the ground, which is now an outpost of Death Valley National Park. Drive a little bit farther, in fact, drive about 100 miles into Death Valley National Park itself and pay the entrance fee at the Furnace Creek Ranger Station and buy yourself some souvenirs. And then you can drive out to a place called Salt Creek and walk a little boardwalk. And the boardwalk goes past a creek that runs for about a mile. In the really hot summer, it might dry up almost all the way to the springs that feed it. If it's not too impossibly hot, you can walk alongside it when it's actively flowing, and you'll find pupfish living in Salt Creek. And they are a different species, Cyprinodon salinus, the Salt Creek pupfish. And the reason it's called Salt Creek is, because the water's salty. There is some kind of underground salt deposit that gets into the water, and it's very salty. It's something like twice the salinity of seawater. It's saltier than the ocean is. And yet these fish do fine. They're one of the few things that does. And then get out of Death Valley, probably take the road over the Panamint Mountains to Highway 395 and head north for a couple of hours. You'll end up in the town of Bishop, California. Pick up a map at the Bureau of Land Management office in town and drive out about 5 miles, and you'll come to a spot called Fish Slough. This is freshwater, but it's colder. You're up at a higher elevation. In fact, Bishop is a really neat town because it's in between two really big mountain ranges, and it's a favored destination for mountain bikers and hikers and skiers and things like that. It's a great place to visit if you get the chance. And in Fish Slough, you will find a fourth species of pupfish, Cyprinodon radiosus. This one's larger. This one lives in fairly cool water. This is the one that used to be much more common in Fish Slough, this whole little patch of wetlands in the middle of high altitude desert. Used to be very common until somebody introduced largemouth bass, which promptly ate them like popcorn. But they've still managed to hang on in shallow areas that the bass can't get into. So if you ever go up that way, go fish some bass and save some pupfish for me. Right. There's the places where they live. You can see LA, San Francisco, and Vegas. That's where the Amargosa pupfish, maybe hour and a half, 2 hours drive out of Las Vegas, is right next to the Devil's Hole. Salt Creek is over in the Death Valley country, and the Owens Valley is farther north up in, the Owens Valley, duh. And here's the thing, each species is restricted to these little isolated pockets of water, these little spring-fed pools or spring-fed ponds, or up in the Owens Valley, kind of a little patch of wetlands. And they're all separated from each other by many miles of desert. There's no way that Amargosa pupfish are going to be able to crawl from where they live to Salt Creek, because it's 100 miles across. You'd have to cross a couple of mountain ranges and cross a bunch of rather harsh desert to get there. So how did the fish get to these isolated pockets? And in fact, the pattern repeats itself if you move farther on. There's about 20 desert pupfish species in the world, in everywhere from West Texas, New Mexico, Arizona, and also in northern Mexico. There's a site in Sonora State called Cuatro Ciénegas, which has a number of them, a lot like Ash Meadows up in Nevada. There's about 20 in all, and almost all of them are restricted to just a few little springs or a few little streams or other little refuges like that. They all tend to live in these very isolated little patches of water, separated from each other by quite a lot of desert. How'd they get there? Well, they didn't get there by crawling from pond to pond, but remember that the climate used to be wetter and cooler out that way, maybe 10,000 years ago, about when the Native Americans were showing up for the first time. And when it's cooler and wetter, those little isolated pockets weren't so isolated anymore. They were connected. Probably all of this pupfish territory, all of these places that we've talked about, used to be connected to the Colorado River system. The Colorado River is now what forms the Grand Canyon and forms that boundary between Arizona and California, and ends up flowing into the Gulf of California south of the town of Mexicali. Probably what happened is that the ancestors of those pupfish spread through that system of connected lakes and rivers. So there was probably one species of pupfish that was able to live all through that river system. And then as climate began changing, because it does, and we can talk more about climate change at the very end. I specifically want to, and certainly, for my money, there's no doubt that humans are causing a lot of the current climate change that we're seeing, but climates do also change naturally for reasons that humanity has nothing to do with. And as the climate began changing at about 10, 11,000 years ago, those rivers began shrinking, the lakes began shrinking, the rivers that used to connect those lakes dried up. They might occasionally refill when there's been heavy rainfall, but most of the time there's no flow in there. So pupfish in one lake would be isolated from pupfish in another lake. And then even the lakes began to shrink until most of them are completely dry, except for occasional heavy rainfalls. I was in Death Valley in 2006, I think, and they had such an unusually high rainfall that the valley temporarily filled up again. But most of the time those lakes dry up, and all that's left is these tiny little pockets where there's enough groundwater to feed, to feed a spring or a pond or a patch of wetlands. So now you have pupfish populations that are still living where they always did, but they're cut off from other populations of their species. They can no longer get from one lake to another. Now that every population's isolated, each one has to adapt by the process of natural selection, because each isolated population is subject to different conditions. At Ash Meadows, the water comes out at perfect bathtub temperature of about 95 to 100 degrees Fahrenheit. It'd be perfect to take a lovely swim in if it wasn't a protected area with many endangered species. Up in Owens Valley to the north, that water gets pretty cold. Salt Creek is pretty warm, but it's also extremely salty. So you have several different sets of water conditions that the pupfish have to adapt to. Different diets, there's different food available in Ash Meadows as opposed to Salt Creek. There's other differences in water chemistry, and all of that sets up natural selection, causing each one of those isolated populations to change and change independently of the others. And le voila, we have new species of pupfish after just a few thousand years. So I'm not going to ask you specific questions about pupfish on the exam, but I reserve the right to ask you questions about how the speciation process works, because you can infer how speciation has worked in things like Caribbean anole lizards, or South Pacific land snails, or cichlid fish from the East African Rift Valley lakes. Or Galapagos finches. There are lots of examples in the natural world that are parallel to this, where even if you're not there to see it directly, you can infer how this process of speciation has happened. You can put together, the biological evidence that you see now with the geographical evidence, what we've talked about as to how we know that these lakes and rivers used to exist, and put it all together into a testable hypothesis. And this is a lot of what evolutionary biologists actually do. And what's more important than you learning about pupfish is learning about how the process happens. So I might well ask you questions that aren't about pupfish, but focus on how allopatric speciation operates, because it happens a lot. Okay, pupfish speciated by allopatric speciation because climate change created a bunch of separate populations. The same thing happened to the minnows. These are three species of a minnow type known as dace, that are found, like the pupfish, they're found in isolated little patches of water, desert lakes, desert streams, desert wetlands in Nevada, Arizona, in the Mojave Desert and the high desert, including at places like Ash Meadows, where they live in some of those springs together with the pupfish. You get the same pattern in snails. Those same little patches of wetlands that contain fish also contain unique snails, and each little pocket of water will have snail species that aren't found anywhere else in the world. It shows up in plants. At Ash Meadows, there's at least 2 species of flower that are not found anywhere else in the world. So that story of populations being divided, and then separated populations adapting to new conditions repeats itself over and over in the western deserts of the United States. And there's lots of variations on this story. I swear I'm only, you're only getting to dip a toe in the water, but this may begin to give you some idea of how we can infer that new species form. is to give you some idea of the logic that we use as to how we can reconstruct the history of life. And we can begin to reconstruct the relationships through common ancestry of all of the species in the world, what we sometimes call the tree of life. Okay, that's actually a pretty good place to take a pause, so I'm going to end things a little bit early. I've got 10:38, so I'm going to let us go early, but we'll start at, so let's do 10:55. That should give you a nice long bathroom break. Recording. Come on, come on, come on. Sorry, my thing's getting a little slow. All right, there I am. So I'm going to stop the presenting. I think I have stopped the presenting. No, stop the presenting. There. And I'm going to stop recording.